Ka of acetic acid is 1.8 times 10 to the negative fifth. What is the Kb of its conjugate base? What's the conjugate base of acetic acid? Acetate ion, right? So what do? We just say Ka times Kb is equal to Kw. So Kb would be Kw divided by Ka. What's Kw? 1.00 times 10 to the negative 14. And what is Ka? 1.8 times 10 to the negative fifth. And that should give you 1 times 10 to the negative 14 divided by 1.8 times 10 to the negative 5. 5.55 times 10 to the negative 10. It's 2 sig figs, so 5.6 times 10 to the negative 10. Okay? Got it? Okay. So here's a clicker question. Which of the following is equal to Kw? What's another way of asking this question? This is all Ka times Kb, right? But the answer is not all of the above, obviously, because I did not give all of the above as a choice. So what's another way of asking this question? Which of these is an acid-base conjugate pair? A conjugate acid-base pair. Let's see how we did. B is a popular answer. Oh, very good. Thank you. Okay. If HCO3 behaves as an acid, then the conjugate base would have one less hydrogen and one less charge, right? HCO3 and HCO3, that's not a conjugate pair. H2CO3 and carbonate, that's 2 hydrogens difference. That's not a conjugate acid-base pair. Okay, so the correct answer is B. All right. How do we explain why sodium acetate is basic? Well, acetate, we say, is the conjugate base of a weak acid, so it's also a weak base. In fact, we just calculated that earlier, right? Its Kb is 5.6 times 10 to the negative 10. So it can react with water to give you acetic acid, HC2H3O2 plus hydroxide. Anytime you're asked to explain why something is basic, look for a reaction that will generate hydroxide. So the way you would explain this, if you went to the lab, you measured the pH of this salt, you'll find it's basic. Okay? And so the way you would explain it is by saying, okay, the negative ion here, the anion, is the conjugate base of a weak acid, so that will react with water to give you hydroxide. And that makes it basic. That's how you explain basic salts. Okay? Now, based on that, the Kb of chloride ion is A, very, very large, or B, very, very small. To help you with this, what is the conjugate acid of Cl minus? HCl, right? What is the Ka of HCl? HCl gives you H plus chloride. What did we know about HCl? It's one of the 6 strong acids. So what's the Ka for this? Keq for this reaction is very large, right? In fact, it is so large that we generally just ignore it. We just say, oh, anytime you have HCl in water, we're just going to dissociate it completely. So this Ka is very, very large. So given that the Ka of HCl is very large, what do you expect the Kb of chloride ion to be? It's got to be very, very small. In fact, chloride ion, okay, if I were to ask you, why is a sodium chloride solution, why doesn't the chloride ion make your water basic? You would say this reaction right here, where chloride reacts with water to give you HCl and hydroxide, okay, this doesn't happen at all, okay, hardly ever happens. because your chloride is a very weak base. Okay, so it cannot pick up a proton from water. HCl is a very strong acid, so it's not going to stay as a molecule in water. So the correct answer for this is B, very, very small. Which of the following has a larger Kb? Nitrite or nitrate, A, or B, nitrite? Let's see. Okay. Nitrate, what's the conjugate acid of nitrate? HNO3, right? And the conjugate acid of HNO nitrate is HNO2. Which of these is a strong acid? This is a strong acid, right? You have to remember your 6 strong acids. There's only 6 to remember, so memorize it. HNO3, HCl, HBr, HI, H2SO4, and HClO4, perchloric acid. Those are your 6 strong acids. So if HNO3 is a strong acid, and HNO2 is not one of the 6, so HNO2 would be what? So weak acid, right? Then, do you want to change your mind? The conjugate of it is going to be very, very weak. So nitrate, you're going to say, it's not going. If you have a nitrate salt, that nitrate's not going to make it. Will have no tendency to make your solution basic. Okay. The cation we've talked about before might make your solution acidic, right? Cations, except for those from group 1A and 2A, have a tendency to hydrolyze and make your solution acidic. Here we can see that negative ions can make your solution basic, provided that they are not one of these anions from these 6 strong acids.